Welcome to the Science Lullaby. I'm really glad you're here. If you're listening to this, you might already be lying down, letting your body rest while your thoughts slowly drift. Or maybe this video is playing quietly in the background as you prepare for sleep. However you've arrived, this is a place designed for calm exploration. There's no rush here, no need to focus intensely or remember everything. This is science at a slower pace, meant to be absorbed gently, even if awareness fades along the way. Tonight, we're exploring one of the most profound questions science has ever faced. A question that sits quietly beneath every thought, every sensation, and every moment of awareness you've ever experienced. That question is consciousness.
Right now, you are aware. You can hear these words. You may notice your breathing, the weight of your body, or the subtle movement of thoughts passing through your mind. This simple fact of awareness feels natural and effortless, yet when scientists attempt to explain how it happens, the mystery becomes surprisingly deep. Consciousness is not something you can point to directly. It has no weight, no shape, and no location you can isolate with a microscope. And yet, without it, there would be no experience at all. No color, no sound, no sense of time, no feeling of being a self moving through the world. Everything you know exists within consciousness. For most of human history, consciousness was not considered a scientific problem. It was treated as something spiritual, philosophical, or divine. Ancient cultures described it as a soul, a life force, or a gift from the gods. Even early scientists avoided the topic, believing it lay outside the reach of measurement and experiment. But over the last century, this view has changed dramatically. Advances in biology, neuroscience, and psychology have made it possible to study the brain in detail. Scientists can now observe neural activity, track information flow, and measure changes in awareness during sleep, anesthesia, and brain injury. As a result, consciousness has slowly moved from the realm of mystery into the realm of investigation. This does not mean the mystery has disappeared. In many ways, it has deepened. The more we learn about the brain, the more puzzling consciousness becomes. Billions of neurons communicate through electrical signals and chemical exchanges. These processes can be described mathematically and observed experimentally. But how do these physical events give rise to experience itself? How does activity in matter become the feeling of being someone? This question is often described as the gap between objective and subjective reality. The brain can be studied from the outside as an object. Consciousness is known only from the inside as experience. Science excels at describing objects, processes, and systems. Experience, however, resists simple explanation. It does not behave like other physical phenomena. Despite this challenge, scientists have not stopped asking the question. Instead, they have reframed it. Rather than asking what consciousness is in an abstract sense, they ask how it functions. What conditions are required for consciousness to appear? drugs, or injury. These changes suggest that consciousness depends on specific patterns of brain activity. When those patterns change, experience changes with them. This dependence has led many scientists to conclude that consciousness is not separate from the brain, but emerges from it. Just as life emerges from complex chemistry, awareness may emerge from complex neural organization. This idea does not make consciousness less remarkable. In fact, it makes it even more extraordinary. From simple biological processes, something capable of reflection, imagination, and meaning arises. Understanding consciousness also forces us to reconsider what it means to be human. Much of what we associate with identity, thoughts, emotions, memories, intentions, exists within conscious awareness. If consciousness is constructed moment by the brain, then the self may be less like a fixed entity and more like an ongoing process. This idea can feel unsettling, but it is also deeply human. It suggests that awareness is dynamic, flexible, and responsive. It adapts to the body, the environment, and the passage of time. It is shaped by both biology and experience. In this video, we'll take our time exploring how consciousness may have emerged, how it is supported by the brain, and how it relates to perception, memory, and reality itself. We'll move slowly, building understanding step by step, without assuming prior knowledge or demanding constant attention. There is no pressure to stay awake for all of it. If your thoughts wander, that's natural. If sleep comes, that's welcome. Consciousness itself is not something you need to control. It arises and fades on its own. To begin this journey properly, we need to step back in time, far before human brains, far before complex thought. We need to ask how awareness might have started in the simplest forms of life, and why it became useful at all. In the next part, we'll explore consciousness before humans existed and look at how basic biological systems may have laid the foundation for awareness as we know it. Long before human brains existed, long before language, memory, or imagination, life was already responding to the world. The earliest living organisms did not think or feel in the way we do, but they were not entirely passive either. They sensed changes in their environment and reacted to them in ways that increased their chances of survival. This simple responsiveness is where many scientists believe the story of consciousness begins. At its most basic level, life needs to distinguish between what is beneficial and what is harmful. Even single-celled organisms can move toward nutrients and away from toxins. They do not experience awareness as we understand it, but they process information. They detect signals, compare conditions, and generate responses. These early forms of biological information processing laid the groundwork for everything that followed. As life became more complex, these basic mechanisms evolved into nervous systems. The first nervous systems did not resemble brains. They were simple networks of cells that transmitted signals across the body. These networks allowed organisms to coordinate movement, respond faster to danger, and adapt more flexibly to their surroundings. With this coordination came a new level of interaction with the world. At this stage, scientists do not speak of full consciousness, but of sentience. Sentience refers to the capacity to have basic experiences, such as sensing light, temperature, or pressure. It does not require self-awareness or reflection. It only requires that an organism can register and respond to stimuli in a unified way. Jellyfish and other simple animals provide useful examples. They have no centralized brain, yet they respond to their environment in coordinated ways. Their nervous systems allow them to sense changes and act accordingly. This suggests that consciousness, or at least its foundations, does not require a complex brain. It requires organized information flow. As evolution continued, nervous systems became more centralized. Instead of signals being distributed evenly across the body, clusters of neurons began to specialize. These clusters formed early brains. Centralization allowed organisms to integrate information from multiple senses and produce more sophisticated responses. Rather than reacting automatically, they could evaluate situations and choose between different actions. With this integration came the beginnings of subjective experience. The organism was no longer just reacting to individual stimuli, but experiencing a unified internal state. Hunger, pain, attraction, and fear became internal signals guiding behavior. These experiences were not thoughts, but they mattered. They shaped decisions and behavior in powerful ways. From an evolutionary perspective, this makes sense. An organism that can feel discomfort avoids danger more effectively. One that can feel pleasure repeats beneficial behaviors. Conscious experience, even in a primitive form, becomes a tool for survival. It compresses complex information into simple signals that guide action. This idea leads many scientists to view consciousness as an adaptive trait. It did not appear suddenly. It developed gradually as nervous systems became more complex and capable of integrating information. Awareness increased in depth and flexibility over millions of years, shaped by environmental pressures and biological constraints. Importantly, this means consciousness did not begin with self-reflection or abstract thought. Those came much later. Early consciousness was likely raw and immediate, focused entirely on the present moment. There was no sense of past or future, no identity, no narrative. There was only sensation and response. As brains grew larger and more interconnected, the range of experiences expanded. Memory allowed organisms to learn from past events. Prediction allowed them to anticipate future outcomes. Attention allowed them to focus on what mattered most. These abilities transformed consciousness from a simple sensory state into a dynamic, adaptive system. At this point, awareness began to include internal states as well as external ones. Organisms could sense not only the world, but their own condition within it. Fatigue, stress, and readiness became part of experience. This internal monitoring further increased survival, allowing more nuanced behavior. Over time, these developments led to the emergence of complex consciousness in mammals and birds. Emotional states, social awareness, and flexible problem-solving became possible. The brain no longer merely reacted. It simulated. It predicted. It evaluated multiple possibilities before acting. This gradual evolution challenges the idea that consciousness is an all-or-nothing phenomenon. Instead, it appears to exist along a spectrum. Different species experience different forms and depths of awareness, shaped by their nervous systems and ecological needs. Understanding consciousness as an evolutionary process helps ground it in biology. It shows that awareness did not appear by accident, nor is it separate from life itself. It is deeply connected to the need to survive, adapt, and interact with a complex world. As we move forward, this raises an important question. If consciousness evolved to help organisms navigate their environment, how exactly does the brain generate conscious experience in the present moment? What mechanisms allow neurons to produce awareness rather than mere reflex? In the next part, we'll examine how the brain organizes perception, memory, and attention to create the continuous experience of being aware. As nervous systems became more complex through evolution, a new challenge emerged. Organisms were no longer responding to just one signal at a time. They were surrounded by a constant stream of sensory information: light, sound, movement, chemical signals, and internal bodily states. To survive, the brain needed a way to organize this information into something coherent and usable. This is where the core mechanisms of conscious experience begin to take shape. The brain does not process the world all at once. Instead, it breaks reality into pieces. Different regions specialize in different tasks. Some areas process visual input, others handle sound, touch, balance, or bodily signals. Still others integrate memory, emotion, and motivation. Conscious experience emerges when these separate processes are coordinated into a unified whole. Perception plays a central role in this process. What you experience as a stable world is not a direct reflection of sensory input. It is an interpretation constructed by the brain. Sensory signals are incomplete and delayed. The brain fills in gaps, smooths over inconsistencies, and creates continuity. This allows you to experience a seamless flow of awareness rather than a fragmented collection of sensations. Memory is essential for this continuity. Without memory, every moment would feel isolated. Short-term memory holds recent information long enough for the brain to compare it with the present. Long-term memory provides context, allowing the brain to recognize patterns and assign meaning. Together, these systems allow conscious experience to feel extended in time rather than confined to a single instant. Attention acts as a filter. The brain cannot process everything with equal depth, so it prioritizes what seems most relevant. Attention enhances certain signals while suppressing others. This is why you can focus on a voice in a crowded room, or become absorbed in a thought while ignoring background noise. Conscious awareness is shaped not only by what is present, but by what the brain chooses to emphasize. These mechanisms operate continuously, even when you are not aware of them. Most of the work that supports consciousness happens beneath awareness itself. The brain prepares interpretations before you notice them. Decisions can begin forming before you feel you have made a choice. Consciousness, in this sense, is the surface layer of a much deeper process.
One way to think about this is that the brain builds a model of the world and of the body within it. This model is updated constantly as new information arrives. When the model is stable and coherent, consciousness feels clear and grounded. When the model is disrupted, experience can become distorted. We see this in cases of brain injury or neurological disorders. Damage to specific regions can alter perception, memory, or the sense of self. Some patients lose awareness of half their visual field. Others feel disconnected from their own body. These conditions reveal that conscious experience depends on precise patterns of neural organization. Sleep provides another important window into how consciousness is constructed. During deep sleep, sensory input is reduced and communication between brain regions changes. Awareness fades, even though the brain remains active. During dreaming, internal activity becomes dominant, and the brain generates vivid experiences without external input. This shows that consciousness does not require the outside world to be present. It can arise from internal processes alone. These observations suggest that consciousness is not tied to any single brain area. It is not located in one place. Instead, it emerges from the interaction of many systems working together. When these systems are synchronized, experience arises. When they are not, consciousness changes or disappears. This view helps explain why consciousness can vary in intensity and clarity. It can be sharp or dull, focused or diffuse. It can narrow during stress or expand during calm states. Consciousness is dynamic, shaped by brain activity, bodily state, and environment. Understanding this dynamic nature moves us closer to answering a deeper question. If consciousness arises from coordinated brain activity, what specific patterns of activity are required? Are there identifiable neural signatures that distinguish conscious states from unconscious ones? In the next part, we'll explore what neuroscience has discovered about the brain activity associated with conscious awareness, and how scientists attempt to measure and define consciousness in the laboratory. To understand consciousness scientifically, researchers needed a way to distinguish conscious states from unconscious ones. This is not as simple as it sounds. Consciousness cannot be observed directly from the outside. It must be inferred from behavior, brain activity, and reports of experience. Over time, neuroscientists began to identify patterns that reliably correlate with conscious awareness. One of the most important discoveries is that consciousness is associated with widespread communication across the brain. When you are awake and aware, many distant brain regions exchange information rapidly and continuously. Sensory areas, memory systems, emotional centers, and decision-making regions all participate in a coordinated network. This integration allows information to be shared and combined, producing a unified experience. When consciousness fades, this integration breaks down. During deep sleep, anesthesia, or coma, brain activity becomes more fragmented. Local regions may remain active, but long-range communication weakens. Information no longer flows freely across the brain. As a result, experience disappears or becomes severely limited.
This observation led to the development of several scientific theories of consciousness.
One influential idea is that consciousness arises when information is both highly differentiated and highly integrated. Differentiation means the brain can represent many distinct states. Integration means these states are unified into a single experience. Consciousness appears when both conditions are met simultaneously. Another closely related theory focuses on global information sharing. According to this view, unconscious processes occur locally within specialized brain regions. Consciousness emerges when information becomes globally available, meaning it can influence perception, memory, reasoning, and action across the entire brain.
In this sense, consciousness acts like a broadcast system, making selected information accessible to many processes at once. Brain imaging studies support this idea. When subjects report conscious perception of a stimulus, activity spreads beyond sensory areas into frontal and parietal regions associated with attention and decision-making. When the same stimulus is presented, but not consciously perceived, activity remains localized. The difference is not the presence of information, but whether it is widely shared. Timing also matters. Conscious perception is not instantaneous. It takes tens to hundreds of milliseconds for sensory information to become conscious. During this time, the brain evaluates, integrates, and amplifies signals.
Consciousness appears to require sustained and coordinated activity rather than brief bursts. These findings challenge the intuition that consciousness is a simple on-off switch. Instead, it behaves more like a graded phenomenon. Awareness can be clearer or dimmer, broader or narrower. This explains why states like drowsiness, meditation, or light anesthesia feel different from full wakefulness, yet are not completely unconscious. Importantly, these neural patterns are not tied to a specific content. The same networks support awareness of sights, sounds, thoughts, and emotions. Consciousness is not about what you experience, but about how experience is processed and shared within the brain. This framework helps explain why machines, despite performing complex computations, are not considered conscious. Current artificial systems process information, but they lack the biological architecture that supports integrated, self-referential experience. They do not possess the kind of global, dynamic organization seen in conscious brains. At the same time, this raises difficult questions. If consciousness depends on certain patterns of information integration, could non-biological systems ever achieve it? Is consciousness tied specifically to living brains, or is it a more general phenomenon that could emerge in other substrates under the right conditions? These questions remain open.
What is clear is that consciousness is not localized to a single point in the brain. It is a process that unfolds over time, supported by networks rather than structures. It depends on balance, coordination, and communication. As we continue, awareness provide that unconscious processing alone cannot. In the next part, we'll explore why consciousness may have been favored by evolution and how it shapes behavior, learning, and survival. From an evolutionary perspective, consciousness would not exist unless it provided some kind of advantage.
Evolution does not favor traits simply because they are interesting or complex. Traits persist because they help organisms survive,
and reproduce. This raises an important question. If much of behavior can be guided by unconscious processes, why did conscious awareness evolve at all? Many basic actions do not require consciousness. Reflexes, habitual movements, and automatic responses operate without awareness. Even complex behaviors, such as driving a familiar route or typing on a keyboard, can occur with minimal conscious involvement. This suggests that consciousness is not necessary for all forms of intelligent behavior. However, consciousness appears to offer flexibility. When conditions are stable and predictable, automatic processes work well. But when situations change, when unexpected events occur, or when multiple goals compete, conscious awareness becomes valuable. It allows organisms to evaluate options, consider consequences, and adjust behavior in novel ways. Consciousness also allows information from different systems to be combined. Hunger, fear, memory, and sensory input can all be brought together into a single decision-making process. This integration supports complex choices that would be difficult to manage through isolated reflexes alone. An organism that can weigh competing needs has a greater chance of navigating a complex environment successfully. Another key advantage of consciousness is learning. Conscious experience makes it possible to reflect on outcomes, form associations, and modify future behavior. Pain and pleasure become signals that guide long-term adaptation rather than immediate reaction. This capacity for flexible learning likely played a crucial role in the evolution of complex animals. Social interaction provides another important context. In social species, understanding others is essential for survival. Consciousness supports the ability to model other minds, predict behavior, and respond appropriately. Empathy, cooperation, and communication all depend on some form of shared awareness. These abilities strengthen social bonds and improve group survival. Language further amplifies this effect. Once organisms can represent experiences symbolically and share them with others, consciousness becomes a tool not only for individual survival, but for cultural transmission. Knowledge can be accumulated across generations, allowing rapid adaptation beyond biological evolution alone. Importantly, consciousness also supports long-term planning. An organism that can imagine future scenarios can act in ways that delay immediate gratification in favor of later benefits. This ability requires maintaining representations of events that have not yet occurred. Conscious awareness provides the mental workspace needed for such simulations. Despite these advantages, consciousness is costly. The brain consumes a significant amount of energy. Maintaining large neural networks and sustained activity requires resources. Evolution would not support this expense unless the benefits were substantial. The fact that consciousness persists suggests that its advantages outweigh its costs in complex environments. This evolutionary view also explains why consciousness varies across species. Different animals face different challenges. Their nervous systems evolve to meet those challenges efficiently. As a result, consciousness is not uniform. It appears in different forms and degrees, shaped by ecological demands and biological constraints. Understanding consciousness as an adaptive process helps demystify it without diminishing its significance. Awareness is not an accidental byproduct. It is a functional feature that supports learning, flexibility, and social interaction. It allows organisms to navigate uncertainty and complexity in ways that purely automatic systems cannot. At the same time, this view raises deeper questions. If consciousness evolved to serve specific functions, is it entirely explained by those functions? Or does subjective experience contain something that cannot be reduced to utility alone? In the next part, we'll explore the limits of functional explanations and examine why consciousness still resists complete scientific understanding, even as we learn more about its mechanisms and evolutionary role. Even with evolutionary explanations, consciousness continues to present a deep scientific challenge. While we can describe what consciousness does and how it may have evolved, there remains a persistent gap between physical processes and subjective experience. This gap becomes especially clear when we ask not how consciousness functions, but why it feels like something at all. From a scientific standpoint, the brain can be described entirely in physical terms.
Neurons fire, chemicals are released, electrical signals propagate through networks. These processes can explain behavior, decision-making, and learning. Yet none of these descriptions seem to capture what it feels like to see a color. This problem is often described as the distinction between objective and subjective explanations. Objective explanations describe systems from the outside. They focus on structure, function, and behavior. Subjective explanations describe experience from the inside. They deal with sensation, awareness, and meaning. Science is highly effective at the first type, but the second resists measurement. Some researchers argue that this gap is only apparent. They suggest that as neuroscience becomes more advanced, subjective experience will eventually be explained in the same way life was explained by biology. Once, life itself seemed mysterious and irreducible. Over time, it became understood as a complex arrangement of chemical processes. Consciousness, they argue, may follow the same path. Others are less confident. They point out that no amount of information about neural activity seems to logically imply experience. You can know everything about how the brain processes color without knowing what red looks like. This suggests that subjective experience may not be fully captured by physical description alone. This debate has led to different philosophical positions within science. Some propose that consciousness is an emergent property. According to this view, experience arises when physical systems reach a certain level of complexity and organization. Consciousness is not present in individual components, but emerges from their interaction, much like liquidity emerges from molecules of water. Another view suggests that consciousness is a fundamental feature of the universe, similar to space, time, or energy. In this perspective, consciousness does not emerge from matter. Instead, matter and consciousness are two aspects of a deeper reality. This idea is sometimes referred to as panpsychism, the view that all matter possesses some form of proto-consciousness.
Panpsychism does not claim that rocks think or feel in the way humans do. Rather, it suggests that the basic ingredients of experience may be present in simple forms throughout nature. Complex consciousness then arises when these basic ingredients are organized in specific ways, such as in brains. This approach attempts to bridge the gap between physics and experience by placing consciousness at the foundation of reality. It avoids the problem of explaining how experience suddenly appears from non-experiential matter. However, it raises its own challenges, including how simple forms of experience combine into the rich consciousness humans experience. Despite these differing views, there is broad agreement on one point. Consciousness is deeply connected to information processing. It involves the integration, differentiation, and interpretation of information within a system. The debate centers on whether this is sufficient to explain experience, or whether something more is required. Importantly, these questions are not merely abstract. They influence how we think about artificial intelligence, animal minds, and even ethical responsibility. If consciousness depends on specific physical patterns, then it may be possible to identify where experience begins and ends. If it is fundamental, then experience may be far more widespread than we currently assume. The difficulty of explaining consciousness fully may reflect a limitation in our current scientific frameworks. Just as classical physics was unable to explain quantum phenomena without new concepts, our understanding of consciousness may require new ideas that have not yet been developed. This does not mean the problem is unsolvable, only that it is unfinished. As you reflect on this, it is worth remembering that science progresses slowly, often by reframing questions rather than answering them directly. Consciousness may not yield to a single explanation, but to a gradual convergence of insights from neuroscience, physics, and philosophy. This brings us to another important domain where consciousness reveals its complexity. If awareness depends on specific brain states, what happens when those states change? How does consciousness alter during sleep, dreams, anesthesia, or altered states? In the next part, we'll explore how consciousness fades, fragments, and transforms across different states, and what these changes reveal about its underlying nature. One of the most revealing ways to understand consciousness is to observe what happens when it changes. Consciousness is not a fixed state that is either fully present or completely absent. Instead, it exists along a continuum. Across sleep, dreams, anesthesia, and altered states, awareness fades, reshapes itself, and sometimes disappears entirely. These transitions offer important clues about how consciousness is generated by the brain. Sleep provides the most familiar example. Each night, consciousness gradually withdraws as the brain shifts through different stages. In deep sleep, awareness of the external world largely vanishes. Sensory input is reduced. Long-range communication between brain regions decreases, and the integrated networks associated with conscious experience become less active. Yet, the brain does not shut down. It remains busy, maintaining bodily functions and reorganizing neural connections.
During dreaming, consciousness returns in a different form. External input is minimal, but internal activity becomes vivid. The brain generates images, emotions, and narratives without sensory guidance. This shows that consciousness does not require interaction with the outside world. It can be constructed entirely from internal signals. Dreams reveal that awareness depends more on how the brain is organized than on what information it receives. Anesthesia offers an even clearer demonstration. Under general anesthesia, consciousness can disappear completely. Patients lose awareness, memory, and the sense of time. Brain activity continues, but the coordinated communication necessary for conscious experience is disrupted.
When anesthesia wears off, consciousness returns, often abruptly, with no awareness of the time that passed. This suggests that consciousness depends on specific patterns of neural interaction rather than overall brain activity. Coma and vegetative states further illustrate this point. Some patients show wakefulness without awareness. Their eyes may open and basic reflexes may remain intact, yet conscious experience appears absent or severely limited. In other cases, minimal consciousness persists, detectable only through subtle brain signals. These conditions reveal that consciousness is not tied to simple indicators like movement or responsiveness, but to deeper neural dynamics.
Altered states such as meditation, hypnosis, or the use of certain substances provide additional insight. In these states, consciousness does not disappear, but changes its structure. The sense of self may weaken. Time may feel distorted. Attention may become more diffuse or intensely focused. These experiences suggest that different aspects of consciousness can be modified independently, depending on which neural systems are engaged. From a scientific perspective, these variations point to consciousness as a process rather than a substance. It arises when certain conditions are met and fades when those conditions change. It can take different forms depending on how information is integrated and prioritized in the brain. This view also challenges the idea that consciousness is synonymous with thought. During many conscious states, thinking is minimal or absent. Awareness can exist without inner dialogue, reflection, or deliberate reasoning. This suggests that consciousness is more fundamental than thought itself. Thinking is something that happens within consciousness, not what defines it. Understanding these states has practical implications. It helps clinicians assess patients who cannot communicate. It informs the safe use of anesthesia. It guides research into disorders of consciousness. More broadly, it deepens our understanding of what it means to be aware. As these observations accumulate, a consistent pattern emerges. Consciousness depends on the brain's ability to integrate information across different regions while maintaining a balance between stability and flexibility. Too much fragmentation and awareness fades. Too much rigidity and experience becomes narrow or distorted. These insights bring us closer to understanding how consciousness operates, but they also raise new questions.
If consciousness can vary so dramatically, what anchors it to a sense of self? Why does awareness usually feel centered around me? In the next part, we'll explore how the brain constructs the sense of self and why identity feels stable even though consciousness is constantly changing. Even though consciousness can fade, fragment, or change shape, it usually feels centered around a stable point of reference. That point is the sense of self. You experience perceptions, thoughts, and emotions as happening to you. This feeling is so familiar that it rarely feels like a construction. Yet neuroscience suggests that the self is not a single entity, but a process the brain continuously generates. The sense of self emerges from multiple systems working together. The brain integrates information about the body, memory, emotion, and intention into a coherent perspective. Signals from the body provide a sense of location and ownership. Memory provides continuity across time. Attention determines what enters awareness. Together, these processes create the feeling of being a subject experiencing the world. Importantly, there is no single self-center in the brain. No specific neuron or region contains identity. Instead, the self is distributed across networks that constantly update. When these networks function smoothly, the sense of self feels unified and stable. When they are disrupted, the experience of identity can change dramatically. Clinical cases reveal this clearly. Some patients with brain damage lose the ability to recognize parts of their own body. Others experience depersonalization, feeling detached from their thoughts or emotions. In rare cases, individuals report feeling as though they are observing themselves from the outside. These experiences show that the self is not fixed, but depends on specific neural processes. Memory plays a crucial role in maintaining identity. Without memory, the sense of being the same person over time collapses. Patients with severe memory loss may remain conscious in the moment, but lack continuity. Each moment feels disconnected from the last. This demonstrates that identity is not inherent to consciousness itself, but arises from how consciousness is linked across time. Prediction is another key component. The brain constantly anticipates the consequences of actions and the flow of experience. This predictive activity contributes to the feeling of agency, the sense that I am doing this. When prediction fails, agency can weaken. Movements may feel involuntary, or thoughts may feel intrusive rather than self-generated. Social interaction further shapes the self. From early development, the brain learns to model other minds. This capacity allows individuals to see themselves as objects of others' attention. Language strengthens this process, enabling the formation of narratives about who one is. These narratives become part of identity, even though they are constructed and revised over time. The fact that the self is constructed does not make it unreal. It makes it functional. The self organizes experience, guides decision-making, and supports social behavior. It provides a reference point that allows consciousness to operate efficiently in a complex environment.
However, recognizing the self as a process rather than an object changes how we understand personal identity. The self is not something you have, it is something your brain does. It is maintained through continuous activity, shaped by biology, experience, and context. This perspective helps explain why the sense of self can soften during meditation or certain altered states. When attention shifts away from internal narratives and bodily monitoring, the processes that support identity become quieter. Consciousness remains, but the feeling of me becomes less pronounced. As we move forward, this understanding raises a deeper question. If the self is a construction and consciousness depends on brain processes, what happens when we imagine consciousness existing beyond the biological brain? Could awareness arise in artificial systems, or is it inseparable from living organisms? In the next part, we'll explore how science approaches the question of artificial consciousness and what current research suggests about the possibility of machine awareness. As our understanding of consciousness deepens, an inevitable question emerges. If awareness arises from specific patterns of information processing in the brain, could similar patterns produce consciousness in non-biological systems? In other words, could a machine ever be conscious? At first glance, modern artificial intelligence appears impressive. Machines can recognize faces, translate languages, compose music, and even simulate conversation. These abilities can resemble intelligent behavior, but intelligence and consciousness are not the same thing. A system can perform complex tasks without experiencing anything at all. From a scientific perspective, the key difference lies in how information is processed and integrated. Current artificial systems operate through specialized modules optimized for specific tasks. While they can handle vast amounts of data, they lack the unified, self-referential integration seen in conscious brains. Their processes remain fragmented rather than globally coordinated. In the human brain, information is constantly shared across many regions. Sensory input, memory, emotion, and bodily state interact continuously. This integration allows experiences to be felt as belonging to a single point of view. Machines, by contrast, process information without a subjective center. There is no internal perspective from which the system experiences its own operations. Another crucial factor is embodiment. Consciousness in biological organisms is deeply connected to the body. Sensations, movement, balance, and internal states all contribute to awareness. The brain evolved to regulate and respond to a living body in a physical environment. This embodied interaction shapes how experience arises. Most artificial systems lack this connection. They do not experience hunger, fatigue, pain, or pleasure. Their inputs and outputs are abstract, disconnected from survival or physical consequence. Some researchers argue that without embodiment, true consciousness may be impossible because experience evolved to guide action in a living world. There is also the issue of development. Human consciousness does not appear fully formed. It develops gradually through interaction with the environment and other minds. Learning, social feedback,
and emotional attachment shape awareness over time. Artificial systems, even those trained on large datasets, do not develop through lived experience in the same way.
Despite these limitations, some scientists believe artificial consciousness is theoretically possible. They argue that if a system were designed with sufficient integration, feedback, and self-modeling, awareness could emerge regardless of the material involved. According to this view, consciousness depends on organization, not biology. Others remain skeptical. They suggest that biological systems possess properties that artificial ones lack, such as complex chemical signaling, adaptive plasticity, and evolutionary history. These features may be essential for generating subjective experience. Without them, machines may remain powerful tools without inner lives. This debate highlights an important distinction. Simulating consciousness is not the same as possessing it. A system can behave as if it is aware without experiencing anything. Determining whether consciousness is present requires criteria that go beyond performance. These questions are not purely theoretical. They influence how we think about responsibility, ethics, and the future of technology. If machines were ever to become conscious, they would raise moral questions about rights and treatment. If they cannot, then their limitations must be clearly understood to avoid confusion. As we reflect on artificial systems, we are reminded of how deeply consciousness is tied to life as we know it. Awareness did not arise in isolation. It emerged within bodies, environments, and social contexts over long periods of time. This brings us back to the human experience. If consciousness depends so strongly on biological and environmental factors, how does it shape our perception of reality itself? Does awareness merely reflect the world, or does it actively participate in constructing what we experience as real? In the next part, we'll explore how consciousness and perception together shape reality, and why the world you experience is not simply given, but continually formed by the mind. As we turn our attention back to everyday experience, it becomes clear that consciousness does more than simply observe reality. It actively shapes it. What you experience as the world is not a raw presentation of external facts, but a constructed interpretation generated by the brain. This construction happens continuously, so smoothly that it usually goes unnoticed. Perception is not a passive process. The brain constantly predicts what it is about to encounter, using past experience to interpret incoming sensory data. When these predictions align with sensory input, experience feels stable and obvious. When they do not, perception adjusts. This process allows the brain to operate efficiently in an uncertain environment, but it also means that experience is always shaped by expectation. This predictive nature of perception explains why reality can feel different under different conditions. Fatigue, stress, emotion, and context all influence what you notice and how it feels. The same environment can appear welcoming or threatening, depending on your internal state. Consciousness does not simply register reality, it filters and organizes it in ways that matter for survival and meaning. Memory further shapes perception. The brain draws on past experiences to interpret the present.
This gives experience continuity, but it also introduces bias. Memories influence attention, expectations, and emotional responses. As a result, reality is never experienced in isolation. It is always colored by what has come before. This interaction between perception and memory creates a personal reality. While the physical world may be shared, the experienced world is unique to each individual. No two people perceive the same moment in exactly the same way. Differences in biology, history, and context shape awareness at every level. From a scientific perspective, this does not mean that reality is purely subjective. There is a stable external world that constrains experience, but it does mean that what consciousness presents is a model of that world, optimized for relevance rather than accuracy. Reality, as experienced, is a useful interface rather than a direct representation. This idea challenges the assumption that consciousness simply mirrors the world. Instead, awareness participates in creating what feels real. It selects, emphasizes, and organizes information in ways that support action and understanding. In doing so, it transforms raw data into meaningful experience. Understanding this process helps explain why illusions, biases, and misperceptions are so common. They are not flaws in the system, but side effects of an efficient design. The brain prioritizes speed and coherence over precision. Most of the time, this works remarkably well. These insights also connect back to earlier discussions of reality and physics. Just as quantum theory suggests that observation plays a role at fundamental levels, neuroscience shows that perception plays a role at experiential levels. In both cases, reality is not independent of interaction. As these ideas come together, a broader picture begins to form. Reality exists, but it is not experienced directly. Consciousness mediates the relationship between the world and the mind, shaping experience in subtle and powerful ways. This raises an important question. If consciousness shapes reality so deeply at the level of experience, how does this influence behavior, decision-making, and meaning in daily life? And what happens when awareness itself changes? In the next part, we'll explore how consciousness guides action, choice, and meaning, and why awareness is central not only to perception, but to how we live and navigate the world. Consciousness does not exist only to perceive the world. It plays a central role in guiding action. Every choice you make, from simple movements to complex decisions, is shaped by conscious awareness interacting with unconscious processes. Together, they allow you to navigate uncertainty, evaluate options, and assign meaning to outcomes. Much of behavior begins unconsciously. The brain constantly prepares actions before you are aware of deciding. Experiments show that neural activity predicting a choice can appear seconds before a person reports having made that choice consciously. This has led some researchers to question whether free will exists at all. If decisions begin unconsciously, what role does consciousness play? Rather than initiating every action, consciousness appears to function as a supervisory system. It monitors ongoing processes, evaluates potential consequences, and can intervene when automatic responses are insufficient. This allows behavior to remain flexible rather than rigid. Conscious awareness provides a space where competing motivations can be compared and adjusted. This supervisory role is especially important in novel situations. When habits fail or when multiple goals conflict, consciousness becomes more engaged. You slow down, reflect, and imagine possible outcomes. This ability to simulate future scenarios allows you to choose actions that align with long-term goals rather than immediate impulses. Emotion is deeply involved in this process. Feelings are not separate from decision-making. They provide value signals that guide attention and choice. Pleasure, fear, curiosity, and discomfort shape priorities and influence behavior. Conscious awareness allows these signals to be experienced and interpreted rather than acted on automatically. Meaning arises through this interaction. Experiences become meaningful when they are integrated into conscious awareness and connected to goals, values, and memory. Without consciousness, events would occur without significance. With it, actions acquire purpose and direction. This does not mean that consciousness controls everything. Much of life operates efficiently without it. But when stakes are high, uncertainty is present, or reflection is needed, awareness becomes central. Consciousness allows learning to extend beyond immediate reinforcement. It supports understanding, planning, and adaptation over time. Importantly, this process is not purely rational. Consciousness does not eliminate bias or error. Instead, it allows biases to be recognized and sometimes corrected. Awareness creates the possibility of change, even if it does not guarantee it. From an evolutionary perspective, this role makes sense. Consciousness enhances behavioral flexibility in complex environments. It supports social interaction, cooperation, and communication. It allows organisms to coordinate actions with others and adjust behavior based on shared understanding. These functions also explain why consciousness feels so central to identity. Decisions, intentions, and values are experienced within awareness. They contribute to the narrative sense of self, the feeling of being an agent rather than a passive observer. Yet this narrative is constructed. It is assembled after actions begin, shaped by memory and interpretation. Consciousness tells a story about behavior, integrating events into a coherent account. This story helps maintain identity and continuity, even when actions originate unconsciously. Understanding this relationship between consciousness and action reframes debates about free will. Rather than seeing free will as absolute control, it can be understood as influence and guidance. Consciousness shapes behavior by providing context, evaluation, and reflection, even if it does not initiate every movement. As we move closer to the end of this exploration, a final question comes into focus. If consciousness shapes perception, action, and meaning, what place does it hold in the larger structure of reality? Is it merely a byproduct of biological processes, or does it reveal something fundamental about the universe itself? In the next part, we'll step back and reflect on how consciousness fits into the broader picture of reality, bringing together insights from neuroscience, physics, and philosophy.
As our exploration widens, consciousness begins to look less like an isolated feature of human brains and more like a phenomenon that sits at the intersection of biology, physics, and philosophy. Each field approaches it differently, yet all point toward the same conclusion. Consciousness cannot be fully understood by examining any single level of reality in isolation. Neuroscience shows how awareness depends on the brain's structure and activity. Physics reveals a universe where observation, information, and interaction play central roles. Philosophy examines the assumptions that connect these perspectives, asking what it means for something to exist or be known. Together, they suggest that consciousness may be a bridge between inner experience and external reality. In physics, the role of the observer has long been controversial. Quantum theory suggests that measurement matters, that reality at the smallest scales does not fully resolve until interaction occurs. While this does not imply that human minds create physical reality, it does imply that interaction is fundamental. Reality is not just there, it unfolds through relationships. Consciousness mirrors this structure at the experiential level. Awareness does not passively receive a finished world. It emerges through interaction between the brain, the body, and the environment. Experience is shaped by attention, memory, and expectation. Just as particles gain properties through interaction, perceptions gain meaning through context. This parallel has led some thinkers to suggest that consciousness may reveal something fundamental about the nature of reality itself. Rather than being an accidental byproduct, awareness may reflect the universe's capacity to organize information in complex, self-referential ways. Consciousness, in this view, is reality becoming aware of itself in localized forms. Others remain cautious. They argue that drawing parallels between physics and consciousness risks over-interpretation. Correlation does not imply equivalence. The fact that observation matters in quantum experiments does not mean that subjective experience plays a role in shaping physical laws. Consciousness, they argue, remains a biological phenomenon grounded in neural activity. Both perspectives highlight the limits of current understanding. Science excels at describing mechanisms, but struggles with meaning. Consciousness brings meaning into the picture, yet resists reduction to mechanism alone. This tension may not indicate a failure of science, but an invitation to expand its conceptual tools. Importantly, this does not require abandoning empirical rigor. It requires recognizing that different questions demand different kinds of explanation. Asking how consciousness works is different from asking why experience exists. Both are valid, but they operate at different levels. As research continues, new approaches attempt to integrate these levels. Some models treat consciousness as an emergent feature of complex systems. Others explore information-based frameworks that unify physical and experiential aspects. None provide a final answer, but each contributes a piece of the puzzle. What becomes clear is that consciousness cannot be fully separated from the reality it experiences. Awareness shapes perception, guides action, and generates meaning. Reality, in turn, constrains and informs awareness.
They exist in a continuous feedback loop.
This perspective encourages a shift in how we think about our place in the universe. Rather than being detached observers, we are participants. Our experiences are part of the unfolding structure of reality, not external to it. As we approach the final sections of this video, it is time to bring these ideas together and consider what they imply for everyday life. If consciousness is central to perception, action, and meaning, how might this understanding change the way we relate to ourselves and the world? In the next part, we'll reflect on the practical and philosophical implications of consciousness and how a scientific understanding of awareness can quietly influence how we live, think, and rest. When we step away from theory and bring these ideas back into daily life, consciousness becomes less abstract and more personal. Understanding awareness as a process shaped by biology, perception, and context can quietly change how we relate to our thoughts, emotions, and experiences. It invites a different way of paying attention to the mind without needing to control it. If consciousness is something the brain continuously constructs, then thoughts are not commands or truths. They are events. They arise, unfold for a moment, and fade. This perspective aligns closely with findings from cognitive science and psychology. Thoughts appear automatically, shaped by memory and prediction. Conscious awareness allows them to be noticed, but not necessarily obeyed. Emotions function in a similar way. They are not signals of objective reality, but internal states that guide behavior. Fear, curiosity, comfort, and unease provide information about relevance, not certainty. When experienced consciously, emotions can be observed rather than reacted to immediately. This space between sensation and response is one of the practical functions of awareness. Attention plays a crucial role here. What you attend to becomes prominent in experience. What you ignore fades into the background. The brain constantly shifts attention based on perceived importance. By understanding this process, it becomes possible to gently redirect attention without force. Awareness itself does not need to be strained. It naturally settles when pressure is removed. This understanding also reframes stress and mental fatigue. When attention is overloaded and predictive systems remain active, consciousness feels restless. When sensory input slows and prediction quiets, awareness becomes calm. This is why rest, sleep, and quiet environments restore mental clarity. They allow the brain's integrative networks to rebalance. Sleep is especially important in this context. During sleep, consciousness withdraws, but the brain continues processing information. Memories are consolidated, emotional responses are adjusted, and neural connections are refined. Conscious awareness is not required for this work to happen. In fact, it may interfere with it. Letting go of awareness allows deeper processes to unfold. Understanding this can make rest feel purposeful rather than passive. Falling asleep is not a loss of control, but a transition into a different mode of brain function. Consciousness fades because it is no longer needed in the same way.
the system shifts priorities from interaction to restoration. This perspective also softens the boundary between waking and sleeping consciousness. Both are natural states supported by the same brain. One emphasizes engagement with the environment.
The other emphasizes internal maintenance. Neither is more real or more important than the other. They serve different functions within the same organism. In moments of quiet awareness, such as just before sleep, the mind can rest without needing to analyze or solve anything. Awareness becomes open and receptive rather than focused. Thoughts may drift, images may appear, and the sense of self may soften. This is not a problem to fix. It is a natural state the brain enters when external demands decrease. From a scientific standpoint, this state reflects reduced top-down control and increased internal coherence. Neural networks associated with narrative identity become less dominant. Sensory and emotional processing slows.
Consciousness becomes simpler, less structured, and more fluid. Recognizing this allows the transition into sleep to happen more easily. There is no need to chase sleep or force relaxation. Consciousness already knows how to fade. It has done so every night of your life. As we move toward the final part of this exploration, we can now see consciousness not as a problem to solve, but as a process to understand. It arises, changes, and recedes according to natural rhythms shaped by biology and environment. In the final section, we'll gently bring this journey to a close, reflecting on consciousness not as a mystery demanding answers, but as an experience unfolding moment by moment, including this one. When the mind is not focused on an external task, it does not become silent. Instead, a specific network in the brain becomes active. Neuroscientists call this network the default mode network. It is one of the most important discoveries in modern brain science, and it plays a central role in consciousness, identity, and inner experience. The default mode network becomes active when you are resting, daydreaming, recalling memories, imagining the future, or reflecting on yourself. It is most active when attention turns inward. This includes moments just before sleep, quiet reflection, and the drifting state between wakefulness and dreaming. In these moments, consciousness does not disappear. It changes its direction. This network connects several brain regions, including areas involved in memory, emotion, and self-referential thinking. When it is active, the brain is not idle. It is busy constructing narratives, revisiting past experiences, and simulating possible futures. Much of what feels like spontaneous thought arises from this network. From the inside, this activity feels like the stream of consciousness. Thoughts appear without effort. Images surface. Memories replay. The sense of self becomes more pronounced. This is the voice in the mind that comments, reflects, and wanders. For many people, This interactivity feels continuous, even unavoidable. Importantly, the default mode network is closely tied to the sense of identity. When it is active, the brain reinforces the feeling of being a self that exists across time. Past experiences are linked to the present. Future possibilities are imagined as belonging to the same individual. This temporal continuity is a core feature of human consciousness. However, this network does not operate in isolation. When attention shifts outward, such as during focused work or problem solving, activity in the default mode network decreases. Other networks take over, supporting attention and action. Consciousness shifts from introspection to engagement with the external world. This balance is crucial. When the default mode network becomes overly active, consciousness can feel restless. Rumination, worry, and repetitive thinking often involve excessive inward focus. The mind becomes trapped in loops of self-referential thought. This is commonly observed in anxiety and depression, where inner narratives dominate awareness. On the other hand, when activity in this network decreases, the sense of self can soften. This occurs during deep focus, meditation, or moments of flow. In these states, awareness remains clear, but the inner narrative quiets. Consciousness feels more immediate and less centered on identity. Scientific studies have shown that during meditation, activity in the default mode network often decreases. Practitioners report a reduced sense of self and a more open awareness. This suggests that the feeling of being a self is not fixed. It depends on how this network is functioning. Sleep offers another perspective. As you fall asleep, activity in the default mode network changes. The narrative stream loosens. Thoughts become less structured. Images may appear without logical connection. This transition marks a shift from waking consciousness to dream consciousness. The self remains present, but its boundaries blur. Dreams themselves often involve fragments of identity rather than a stable sense of self. You may act, observe, or shift perspectives without questioning it. This reflects altered coordination between networks that support narrative identity and those that generate sensory experience. Consciousness remains, but the default mode network no longer organizes experience in the same way. This reveals an important insight. Consciousness does not require a strong sense of self. Awareness can exist without a coherent narrative identity. The self is something consciousness does, not something it always needs. From an evolutionary perspective, the default mode network likely developed to support planning and social cognition. Imagining future scenarios, reflecting on past actions, and understanding others' perspectives are powerful tools for survival in complex social environments. The cost is a mind that rarely rests completely. Understanding this network helps explain why quiet moments can feel mentally busy. When external demands decrease, inward activity increases. The brain fills the space with thought. This is not a flaw. It is a feature of how consciousness organizes itself. However, it also explains why constant mental noise can feel exhausting. the default mode network consumes energy. When it remains active without balance, awareness becomes overloaded. Rest does not come easily. Sleep becomes harder to enter. This is why gentle attention shifts, such as listening to calm narration or ambient sound, can help with sleep. They provide just enough external focus to reduce inward rumination without demanding effort. The default mode network quiets gradually, allowing consciousness to drift.
From a scientific perspective, this transition is not a loss of awareness, but a reorganization of it. Consciousness changes shape as networks rebalance. Identity loosens. Time perception fades. The brain prepares for a different mode of operation. Recognizing this helps reframe moments of mental wandering. They are not distractions to eliminate, but natural expressions of how the brain maintains identity and continuity. At the same time, they do not define the entirety of consciousness. This brings us to a deeper and more unsettling question. If the sense of self depends on specific brain networks, what happens when those networks are physically separated? Could consciousness itself divide? In the next part, we'll explore split brain experiments and what they reveal about the possibility of multiple centers of awareness within a single brain. In the middle of the 20th century, a series of neurological experiments forced scientists to confront a deeply unsettling idea. What if consciousness is not always unified? What if a single brain can give rise to more than one center of awareness? These questions emerged from research on patients who underwent a procedure known as corpus callosotomy. This surgery was performed as a last resort to treat severe epilepsy. It involved cutting the corpus callosumum, the large bundle of nerve fibers that connects the left and right hemispheres of the brain. The goal was to prevent epileptic seizures from spreading from one hemisphere to the other. After the surgery, patients appeared mostly normal in everyday life. They could speak, move, and interact with others without obvious difficulty. But under controlled experimental conditions, something remarkable became clear. The two hemispheres of the brain were no longer sharing information in the usual way. Each side was processing the world independently. To understand why this matters, it helps to know that the two hemispheres specialize in different functions. In most people, the left hemisphere is more involved in language, logic, and sequential reasoning. The right hemisphere plays a larger role in spatial awareness, emotional processing, and visual integration. Under normal conditions, these differences are coordinated through constant communication. When that communication is severed, each hemisphere begins to operate with a degree of independence. In experiments, information presented to the right visual field, which is processed by the left hemisphere, could be verbally reported by the patient. Information presented to the left visual field, processed by the right hemisphere, often could not be named, even though the patient clearly responded to it in other ways. If an object was placed in the left hand, controlled by the right hemisphere, the patient might be unable to name it. Yet the same hand could select the correct object from a group without difficulty. This suggested that the right hemisphere perceived and understood the object, but could not communicate that knowledge verbally. More strikingly, some experiments revealed conflicting intentions. In rare cases,
one hand might perform an action that the other hand seemed to oppose. Patients sometimes reported feeling as though one hand had a mind of its own. These experiences were not signs of confusion or delusion. They reflected genuine independence between hemispheres. From a scientific perspective, these findings were profound. They suggested that consciousness may not be a single, indivisible thing. Instead, it may arise from integrated communication across brain systems. When that integration is disrupted, multiple streams of awareness can emerge. This does not mean that split-brain patients have two fully independent selves. Their experiences are more subtle and complex. In daily life, environmental cues and learned habits help maintain coherence. But under experimental conditions, the separation becomes apparent. These observations challenge the intuition that there is always one conscious subject inside the brain. Instead, they suggest that unity is something the brain actively maintains. Consciousness feels unified because information is shared across networks. When that sharing is interrupted, unity weakens. This has important implications for theories of consciousness. It supports the idea that awareness depends on integration rather than location. There is no central observer hidden in the brain. Consciousness emerges from coordinated activity. When coordination changes, the structure of awareness changes with it. The split brain findings also complicate the concept of identity. If different parts of the brain can support distinct streams of experience, then identity may not be as singular as it feels. The sense of being one person may depend on the brain's ability to synchronize its processes. Importantly, these results do not imply that the self is an illusion. They suggest that the self is a construction maintained by communication. When communication is intact, identity feels stable. When it is disrupted, the boundaries of the self can shift. These experiments also highlight the limits of introspection. A split-brain patient may sincerely report a unified experience, even when behavior reveals divided processing. This suggests that consciousness does not have complete access to all underlying processes. Awareness is partial, shaped by what is integrated and reportable. From a broader perspective, split-brain research reinforces a recurring theme. Consciousness is not an all-or-nothing property. It is structured, distributed, and dependent on relationships between brain systems. Unity is something achieved, not something given. This understanding leads naturally to another question. If consciousness can exist in divided forms within a single brain, how widespread is consciousness across different forms of life? Is awareness unique to humans? Or does it appear in other species in ways we are only beginning to understand? In the next part, we'll explore animal consciousness and examine what science can say about awareness beyond the human mind. For a long time, consciousness was considered uniquely human. Animals were often viewed as complex machines, driven by instinct rather than experience. This view has gradually changed as scientific evidence has accumulated. Today, many researchers believe that consciousness exists across a wide range of species, though not in the same form or depth as in humans. The difficulty in studying animal consciousness lies in the absence of language. Animals cannot describe their experiences. Scientists must rely on behavior, brain structure, and neural activity to infer the presence of awareness. This requires careful interpretation and a willingness to avoid projecting human experiences where they may not apply. One of the strongest indicators of consciousness is flexible behavior. Animals that can adapt to new situations, solve problems, and learn from experience are likely processing information in ways that go beyond simple reflexes. Studies show that many animals, including mammals, birds, and even some invertebrates, exhibit this kind of flexibility. Brain anatomy provides further clues. While animal brains differ in size and structure, many share key features associated with consciousness in humans. These include networks that integrate sensory information, memory, and emotion. For example, mammals possess thalamocortical systems that support coordinated awareness. Birds, despite lacking a cortex structured like ours, have different neural architectures that perform similar integrative functions.
Behavioral studies reinforce these findings. Some animals demonstrate self-recognition, a trait often associated with higher awareness. Others show evidence of planning, social understanding, and even empathy. These abilities suggest that animals are not merely reacting to stimuli, but experiencing internal states that guide behavior. Pain perception offers a particularly important window into animal consciousness. Pain is not just a reflex. It involves an unpleasant, subjective experience that motivates avoidance. Research shows that many animals exhibit behavioral and physiological responses consistent with pain experience, not just nociception. This has significant ethical implications, influencing how humans think about animal welfare. Sleep and dreaming also provide insight. Many animals experience sleep cycles similar to those in humans, including phases resembling REM sleep. During these phases, neural activity patterns suggest internal processing disconnected from the external environment. While we cannot know the content of animal dreams, their presence suggests that animals have internal experiences beyond immediate perception. Importantly, animal consciousness likely varies widely. It is not a single property that animals either possess or lack. Instead, it appears along a spectrum. Different species experience different forms of awareness, shaped by their ecological needs, sensory systems, and nervous system complexity. An animal that relies heavily on vision will experience reality differently from one that depends on smell or echolocation. Consciousness is not a universal template. It is adapted to the world an organism must navigate. What matters is not similarity to human experience, but coherence within the animal's own context. This perspective challenges anthropocentric assumptions. Consciousness does not require language, abstract reasoning, or self-reflection. These are advanced features that build on more basic forms of awareness. At its core, consciousness involves the ability to integrate information and generate experience that matters to the organism. Understanding animal consciousness also informs our understanding of human consciousness. By examining simpler systems, scientists can identify which features are essential and which are specialized. This comparative approach helps isolate the core mechanisms of awareness. However, there are limits to what science can currently determine. Consciousness is inferred, not observed directly. While evidence strongly suggests that many animals are conscious, the precise nature of their experience remains unknown. This uncertainty calls for humility in interpretation and caution in ethical decisions. As research continues, the line between conscious and non-conscious organisms becomes less clear. Instead of a sharp boundary, there appears to be a gradual transition. Awareness increases in richness as nervous systems become more complex and integrated. This realization broadens the concept of consciousness beyond the human mind. It suggests that awareness is not an exception in nature, but a natural outcome of biological organization under certain conditions. As we move forward, this raises another foundational question. If consciousness appears across species, when does it first emerge in an individual life? How early does awareness begin? And how does it develop from infancy into the complex experience of adulthood? In the next part, we'll explore the development of consciousness in infants and examine what science can tell us about the earliest stages of awareness. Language feels inseparable from conscious thought. Much of what we experience internally appears as words, sentences, and inner narration. This makes it tempting to assume that language is a requirement for consciousness itself. Scientific evidence, however, suggests a more nuanced relationship. Language powerfully shapes consciousness, but it does not create it from nothing. To understand this distinction, it helps to separate experience from description. Consciousness involves having experiences. Language involves labeling, organizing, and communicating those experiences. While the two interact closely in humans, they are not identical processes. Neuroscience supports this separation. Brain regions involved in language are distinct from those involved in basic awareness. Damage to language areas can severely impair speech and comprehension, while leaving perception, emotion, and awareness intact. Patients with aphasia may struggle to find words, yet still experience pain, pleasure, fear, and visual imagery clearly. This suggests that consciousness can exist without linguistic structure. Awareness does not depend on words, but words reshape how awareness is organized. Language introduces categories, boundaries, and narratives that structure experience over time. It allows thoughts to become explicit, stable, and shareable. Before language develops, as in infancy, consciousness is present but unstructured. Experience flows without labels. Sensations and emotions arise and fade without being named. This does not make them weaker, but different. Language adds a layer of interpretation that changes how experience is remembered and reflected upon. Even in adults, moments without language reveal this distinction. During intense focus, physical exertion, or deep relaxation, inner narration may quiet. Awareness remains, sometimes becoming clearer rather than diminished.
This shows that consciousness does not rely on constant verbal thought. Meditative practices provide further evidence. Many techniques aim to reduce internal speech. Practitioners report states of clear awareness with minimal or no inner dialogue. Brain imaging studies show reduced activity in language-related regions during these states, while awareness-related networks remain active. At the same time, language profoundly extends consciousness. It allows abstract thought, complex planning, and symbolic reasoning. Through language, humans can reflect on experiences long after they occur, imagine hypothetical futures, and construct detailed personal narratives. This creates a layered form of awareness that extends beyond the present moment. Language also shapes the sense of self. Internal narration reinforces identity by telling a continuous story about who one is. Thoughts about the past and future are organized linguistically, creating coherence across time. Without language, the sense of self becomes more immediate and less narrative-driven. Cross-cultural studies highlight this influence. Different languages categorize reality in different ways. This affects how speakers perceive color, time, space, and emotion. Consciousness adapts to the symbolic structures it uses, while the underlying capacity for awareness remains. The content and organization of experience change. Importantly, this does not mean that language determines consciousness entirely. Rather, it acts as a lens. It highlights certain aspects of experience while downplaying others. What cannot be easily named may receive less attention, even if it is present. This has implications for understanding non-human and pre-linguistic consciousness. Animals and infants may lack language, but they are not devoid of experience. Their awareness is shaped by perception, emotion, and action, rather than symbolic narration. Consciousness exists, but in a form that is immediate, rather than reflective. The relationship between language and consciousness also informs debates about artificial intelligence. Systems that process language fluently may appear conscious, but linguistic output alone does not guarantee awareness. Language can be simulated without experience. Consciousness requires more than symbolic manipulation. At the same time, if a system were ever to develop genuine awareness, language would likely transform that awareness, just as it does in humans. Language would not create consciousness, but it would expand and organize it. Understanding this relationship helps clarify why silence can feel calming. When inner narration slows, consciousness becomes less fragmented. Attention shifts from verbal interpretation to direct experience. This transition often occurs naturally as one prepares for sleep. As language quiets, awareness does not vanish, it changes its mode. Sensations become softer. Time feels less structured. The sense of self loosens. The mind prepares to enter a different state of consciousness. This transition highlights a final important point. Consciousness is not bound to any single form. It can be verbal or nonverbal, reflective or immediate, structured or diffuse. Language is one way consciousness expresses itself, not the source from which it arises. As we move closer to the end of this exploration, we now turn to a domain where language often fails entirely, experiences that feel beyond words, yet deeply conscious. In the next part, we'll examine near-death experiences and extreme states of awareness and explore how the brain may generate them. Near-death experiences have fascinated scientists, physicians, and philosophers for decades. People who survive cardiac arrest, severe trauma, or medical emergencies sometimes report vivid experiences that occur when the brain is under extreme stress. These experiences often include a sense of leaving the body, moving through darkness or light, intense emotions, and a feeling of clarity or peace. Because these reports are consistent across cultures, they raise difficult questions about consciousness at the edge of life. From a scientific perspective, the first task is to understand what is happening in the brain during these events. Near-death experiences do not occur during actual brain death, but during periods when normal brain function is severely disrupted. Oxygen levels drop, blood flow decreases, and neural activity becomes unstable. These conditions dramatically alter how information is processed. One well-supported explanation involves oxygen deprivation. When the brain receives insufficient oxygen, visual and spatial processing areas are affected first. This can produce tunnel-like visual effects and distortions of space. The sensation of moving through a tunnel toward light may reflect how the visual cortex responds to uneven loss of input. Neurochemical changes also play a role. Under extreme stress, the brain releases large amounts of neurotransmitters and neuromodulators, including endorphins and dopamine. Endorphins can reduce pain and create feelings of calm or euphoria. Dopamine influences perception and salience, making experiences feel intense and meaningful. Together, these chemicals can generate powerful subjective states. The sense of leaving the body is often linked to disruptions in the temporoparietal junction, a brain region involved in integrating sensory information about the body's position in space. When this integration fails, the brain's representation of the body can become unstable, leading to experiences of disembodiment or observing oneself from an external perspective. Memory and expectation also shape these experiences. Cultural beliefs, personal expectations, and prior knowledge influence how sensations are interpreted. While the core features of near-death experiences appear similar across cultures, the details often reflect individual belief systems. This suggests that the brain draws on existing frameworks to organize unusual sensations into coherent narratives. Importantly, near-death experiences feel real to those who have them. The clarity and emotional intensity can surpass ordinary waking consciousness. This does not mean that the experiences reflect an external reality beyond the brain. It means that the brain, even under extreme conditions, can generate highly structured and convincing experiences. Some researchers have proposed that near-death experiences reveal a form of consciousness independent of the brain. However, current scientific evidence does not support this conclusion. All observed features can be linked to known neural mechanisms operating under extreme stress. The fact that similar experiences can be induced through stimulation, drugs, or sensory deprivation supports a brain-based explanation. That said, near-death experiences still challenge simple models of consciousness. They show that awareness can persist and even intensify when normal brain function is compromised. This suggests that consciousness does not require optimal conditions. It can arise from unstable and chaotic neural activity, producing experiences that feel profound and transformative. These experiences often have lasting psychological effects.
Many individuals report changes in values, reduced fear of death, and increased appreciation for life. From a scientific perspective, this reflects how emotionally powerful experiences reshape memory and meaning. Consciousness is not only about moment-to-moment awareness, it also influences long-term interpretation of life events. Near-death experiences also highlight the brain's capacity to construct coherent experience from limited input. When sensory information is reduced or distorted, the brain fills in gaps using memory and imagination. This capacity normally supports perception, but under extreme conditions, it can produce extraordinary experiences. Understanding these mechanisms does not diminish the personal significance of near-death experiences. Science does not evaluate meaning. It explains processes. An experience can be neurologically generated and still feel deeply meaningful to the person who has it. These findings reinforce a central theme. Consciousness is resilient. It adapts to changing conditions and can take unexpected forms. Awareness does not simply shut down when systems are stressed. It reorganizes. As we continue, this leads to another domain where consciousness appears altered in striking ways, yet remains firmly tied to brain activity. In the next part, we'll explore how altered states induced by certain substances affect consciousness and what they reveal about the brain's capacity to reshape experience. Altered states of consciousness induced by certain substances have provided scientists with a unique window into how the brain constructs experience. Unlike near-death states, these conditions occur while the brain remains alive and measurable, allowing researchers to observe how changes in neural activity reshape awareness in real time. Substances such as psilocybin, LSD, and certain dissociative compounds do not introduce new information into the brain. Instead, they change how existing information is processed, filtered, and integrated. This makes them especially valuable for studying consciousness because they reveal which aspects of awareness depend on specific neural patterns. One of the most consistent findings across studies is a change in communication between brain networks. Under normal waking conditions, different networks maintain relatively stable roles. Some are involved in attention, others in self-referential thinking, others in sensory processing. Altered states disrupt these boundaries. In particular, activity in the default mode network often decreases significantly. As this network quiets, the sense of self weakens,
people report feeling less defined, less separate from their surroundings. Thoughts become less narrative-driven. Experience feels more immediate and less centered on identity. At the same time, connectivity between sensory regions increases. Areas of the brain that do not normally communicate directly begin to exchange information. This can result in synesthetic experiences, where sounds are perceived as colors, or shapes feel emotionally charged. The brain becomes more globally interconnected, but less constrained. From the inside, this reorganization feels like an expansion of consciousness. Boundaries dissolve. Time may feel distorted or irrelevant. Attention becomes fluid rather than focused. Importantly, these experiences are not random. They follow predictable neural patterns that can be measured using brain imaging. Emotion is also amplified.
Reduced filtering allows feelings to emerge with greater intensity. Joy, fear, awe, and insight can all feel overwhelming. This is not because emotions are new, but because the systems that normally regulate and suppress them are less active. Memory and meaning are particularly affected. Experiences during altered states often feel deeply significant, even when they involve simple sensations or abstract imagery. This sense of meaning reflects heightened emotional salience, combined with reduced critical evaluation. The brain treats internal events as important, without filtering them through usual interpretive frameworks. These states also reveal how fragile the sense of self can be. Identity depends on stable patterns of neural activity. When those patterns change, the feeling of being a separate individual can fade or fragment, yet awareness itself often remains vivid. This reinforces the idea that consciousness does not depend on a strong sense of self. From a scientific perspective, these findings support models that link consciousness to information integration rather than specific content. Altered states demonstrate that changing the balance of integration and segregation in the brain reshapes awareness without eliminating it. Importantly, these states are temporary. As the brain returns to its usual organization, consciousness restabilizes, the sense of self reforms, narrative thought returns. This reversibility allows scientists to compare states directly and identify which neural changes correspond to specific experiential effects. These observations also highlight risks. Because filtering and regulation are reduced, altered states can amplify distress as easily as insight. The same mechanisms that allow profound experiences can also produce confusion or anxiety. This underscores the importance of context, environment, and psychological state. From a broader perspective, altered states challenge assumptions about normal consciousness. They show that ordinary awareness is just one configuration among many. The brain has multiple modes of operation, each capable of supporting experience. Consciousness is not fixed. It is adaptable. These findings also inform discussions about therapy and mental health.
carefully controlled use of certain substances is being explored as a way to disrupt rigid patterns of thought in conditions like depression. The goal is not to escape consciousness, but to temporarily loosen its structure. Despite their dramatic effects, altered states do not imply access to hidden realities beyond the brain. They demonstrate how changes in neural organization transform experience. Meaning arises from the brain's interpretation of its own activity. As we move forward, these insights bring us to a sobering realization. Even with all this knowledge, consciousness remains partially unexplained. Science can map correlations, describe mechanisms, and predict changes, yet something remains elusive. In the next part, we'll confront the limits of scientific explanation and explore why consciousness continues to resist a complete account, even as our understanding deepens. Despite decades of research, increasingly sophisticated tools, and vast amounts of data, consciousness remains only partially explained. Neuroscience has identified many of the mechanisms that correlate with awareness, yet a complete account still feels out of reach. This is not because science has failed, but because consciousness presents a unique kind of problem. Science is built to explain structures, functions, and relationships. It excels at describing how systems behave and how components interact. Consciousness, however, includes a first-person dimension that does not easily fit into this framework. No matter how detailed a neural description becomes, it does not seem to capture what experience feels like from the inside. This gap has been called the explanatory gap. It refers to the apparent distance between objective descriptions of brain activity and subjective experience itself. You can explain how the brain processes visual information, how neurons encode color, and how signals reach the visual cortex. Yet none of this explains why seeing blue feels the way it does. Some researchers argue that this gap is only temporary. They believe that as science advances, subjective experience will eventually be explained in physical terms, just as life, heat, and electricity once were. According to this view, consciousness feels mysterious only because we lack the right concepts. Others are less optimistic. They suggest that consciousness may require a different kind of explanation altogether. It may not be reducible to physical processes in the same way other phenomena are. This does not mean it is supernatural, but that it may require a new framework that integrates subjective and objective perspectives. One reason consciousness is so difficult to explain is that it cannot be observed directly. Scientists study it indirectly through reports, behavior, and neural correlates, but these are proxies. They point to consciousness without revealing it. The experience itself remains private. This limitation does not apply to most scientific subjects. A molecule, a cell, or a star can be observed, measured, and shared across observers. Consciousness cannot. Each instance exists only for the individual experiencing it. This makes it resistant to standard methods of verification. Another challenge lies in defining consciousness precisely. Researchers use the term to refer to different things, including awareness, wakefulness, self-reflection, and subjective experience. These aspects can vary independently.
A system may be awake without being self-aware, or aware without being able to report experience. Without a single definition, explanations fragment. There is also the problem of scale. Consciousness emerges from interactions across billions of neurons, operating at multiple timescales. Capturing this complexity in a unified theory is an enormous task. Simplified models reveal patterns, but they may miss essential features of experience. Some scientists propose that consciousness may be an emergent phenomenon, similar to how temperature emerges from molecular motion. In this view, experience arises when systems reach a certain level of complexity and integration. Consciousness is real, but not fundamental. It depends entirely on underlying processes. Others propose that consciousness may be fundamental, like space or time. In this view, physical systems do not produce consciousness, they organize it. Awareness exists as a basic feature of reality, expressed differently depending on structure. This approach attempts to dissolve the explanatory gap by placing experience at the foundation. Both perspectives face challenges. Emergent views struggle to explain why experience appears at all. Fundamental views struggle to explain how simple forms of consciousness combine into complex ones. Neither has resolved the issue conclusively. What is clear is that consciousness sits at the edge of current scientific understanding. It exposes the limits of existing frameworks. This does not mean it is beyond science forever. It suggests that progress may require conceptual shifts rather than incremental data alone. Historically, major advances in science have often involved rethinking basic assumptions. The nature of space, time, and matter all required radical changes in perspective. Consciousness may demand something similar. It may require new ways of integrating subjective experience into objective models. Importantly, acknowledging these limits does not diminish scientific inquiry, it clarifies it. Science advances not only by solving problems, but by recognizing which questions are not yet fully answerable. Consciousness may remain partially mysterious for some time, but even incomplete understanding has value. It informs medicine, psychology, technology, and ethics. It shapes how we think about ourselves and others. As we reach the final section of this journey, it becomes clear that consciousness does not need to be fully explained to be meaningful. It is present in every moment of awareness, including this one. In the final part, we'll bring this exploration to a close, reflecting on consciousness not as a problem to be solved, but as an experience that unfolds naturally, inviting curiosity rather than certainty. As we reach the end of this exploration, it may feel tempting to look back and ask what consciousness truly is. After examining the brain, behavior, development, altered states, and the limits of explanation, the most honest answer is not a single definition, but a perspective. Consciousness is not a thing hidden somewhere in the brain. It is not a switch that turns on or off. It is a process that unfolds. It arises when systems interact in specific ways, when information is integrated, when awareness becomes possible. It changes with context, with biology, with state,
It appears, reshapes itself, and fades, only to return again. Throughout this journey, one pattern has remained consistent. Consciousness is deeply tied to organization rather than substance. It depends less on what the brain is made of and more on how it functions as a whole.
When communication flows, awareness emerges. When integration breaks down, experience fragments or disappears. This understanding removes some of the mystery without removing the wonder. Consciousness does not become less meaningful because it is natural. If anything, it becomes more remarkable. Every moment of awareness represents an extraordinary coordination of processes shaped by evolution, development, and experience. At the same time, science reminds us of humility. There are limits to what can currently be explained. Subjective experience resists complete capture by objective description. This does not mean consciousness is beyond understanding. Only that understanding unfolds gradually, just like awareness itself. In daily life, consciousness rarely demands explanation. It simply is. You experience thoughts, sensations, emotions, and images without needing to know how they arise. The brain handles the mechanics quietly in the background. Awareness floats on the surface of this activity, present without effort. As attention softens, consciousness naturally shifts. Thoughts slow. The sense of time loosens. The boundaries of identity become less defined. This is not a loss. It is a return to a simpler mode of experience, one where awareness does not need to analyze or interpret, only to exist. Sleep is one expression of this transition. Consciousness withdraws because it is no longer needed in the same way. The brain enters a different mode of organization, one focused on restoration rather than interaction. Awareness fades, not because something has gone wrong, but because the system is doing exactly what it is designed to do. Understanding this can make letting go easier. There is no need to chase sleep or control the mind. Consciousness knows how to rest. It has practiced this rhythm for as long as the brain has existed. From a broader perspective, consciousness connects us to something shared. While experiences differ, the capacity for awareness unites living systems. It is present in many forms, across species, across development, across states. It is not owned by thought or language or identity. It appears wherever conditions allow. Science may continue to explore its mechanisms, map its correlates, and refine its theories, but consciousness itself does not wait for explanation. It unfolds moment by moment, quietly, reliably, even now. As this video comes to a close, there is nothing you need to do, no conclusion to reach, no idea to hold on to. Awareness can simply soften and drift, just as it naturally does. Whatever comes next, whether thought, image, or rest, will arise on its own. And when consciousness fades into sleep, it does not disappear. It changes its form.
That too is part of the same continuous process. You can let it happen now.